14-3 is where Unit 12, our factoring favorite unit, comes in. And our Unit 13, solve quadratics by setting them equal to 0, comes in. And graphing of the quadratics all becomes intermixed. So if I solve by factoring, I do multiple of -6, addition to 5. These are different. This is large. And so I have x plus 6 and x minus 1 equals 0. And then to solve for x, I say x plus 6 equals 0 and x minus 1 equals 0. X equals -6, x equals 1. Here is something you need to pay attention to. My factors are x plus 6 and x minus 1. So if I ask you for the factors, you must write x plus 6 and x minus 1. Those are factors. You cannot just say 6 and 1. If I want solutions, you are then going to write -6 and -1. Ooh, +1. Sorry, +1. So, and if you have factors, you can say opposite and opposite. That's how they work out. Okay? That's how those work out. Now, there are some terms, and the terms are solutions, roots, zeros, x-intercept. Okay? All of these things are asking for this right here. I can do the entire problem and say, here's your equation, what are the solutions? Here's the equation, what are the roots? Here's the equation, what are the zeros? Here's the equation, what is the x-intercept? Absolutely everything I just asked is the answer of this. Okay, so make sure you know how to do those. Okay, here we go. We are going to graph the quadratic equations, find the x-intercept, solutions, factors, vertex, y values for the given x values, sketch the graph, and find the axis of symmetry. Okay, we can do them in any order. I typically don't do things in the correct order anyways. Vertex, opposite b over 2a. Opposite of -8 over 2 times 1, 8 over 1. Axis is 4, so my axis of symmetry, whoo, sorry, I did all of that in the wrong place. -8, -8. Ugh. Let me fix all this. -8 over 2 times 1 equals 4. X equals 4. Yes, I have to have that it is x equals 4. Because in Algebra 1, you get x equals numbers. Okay, axis of symmetry. So now I have to plug the 4 in. So it's 4 squared minus 8 times 4. Put these in parentheses plus 15. 16 minus 32 plus 15. -1. So my vertex is at 4, -1. 1, 2, 3, 4, and -1. There is a positive coefficient, therefore it's a max. My factors are same, large, multiply to 15, 1 times 15, add to -8, x minus 3, and x plus 5. So my factors are x minus 3 and x plus 5. When I set each of these equal to 0, I can do it from just looking where I would do x minus 3 equals 0. It comes over, so x equals 3. And x plus 5 equals 0. So x equals -5. So it's -3. And whoops, positive 3 and negative 5. Positive 3 and, oh, that's a negative. Whew. Notice if you mess up these, it's a domino effect. That's minus 5, that's minus 5, so that's plus 5, so that's plus 5. X-intercept is the same thing as a solution, but x-intercept has to be a coordinate point, so it's 3, 0 and 5, 0 and everything. Oh, so, okay, so 1, 2, 3, 0 and 5, 0, and it does indeed open up. So, oh, and x equals 1. I have to figure that out. So 1 squared minus 8 times 1 plus 15. 1 minus 8 plus 15. 16 minus 8 is 8. And then I do 8 squared minus 8 times 8 plus 15. That and that cancels out, so I get 15. 8 is 15. So that's how you would do shown work on x-intercepts. And remember, x-intercepts and solutions are the same thing. Factors are with your parentheses.